Another question, which is actually a simultaneous equation, but there is a square root involved. The question is like that: square root of x plus y is equal to 7. Then x plus square root of y is equal to 11. Now, to solve this, now you take, if you want to square it and then remove the square root and all this thing, it will be very complicated. Go other way around. Assume that this square root of y, y is square root of y to power of 2. So it will be easier for you to handle it. Now, some people, for better understanding, they will change the variable. So I am not going to do that. Then I'm trying to write all these things in the terms of a square root. So, but it's given to us x and y are natural numbers, or positive integers, z plus, or you can say they are natural numbers. Okay, if I subtract this, I'm going to get, if you call this one 1, equation 1, and this one equation 2, I will equation 2 minus equation 1. I'm going to get a square root of x, x minus the square root of x plus the square root of y minus y is equal to 11 minus 7. I rearrange these. I will write these two next to each other. Therefore, x minus y, and I have minus the square root of x plus the square root of y is equal to, this will be 4. Now, x minus y, I told you this is, you can assume that this is a square root of x to power of 2, and the y will be a square root of y to power of 2. So I can write, use the conjugate theorem, this part is a square root of x minus a square root of y times a square root of x plus a square root of y now. You can see you have got a square root of x minus a square root of y, but this is other way around. I will factorize one negative from here, so I'm getting a square root of x minus a square root of y is equal to 4. Now you can see that these two are common. Therefore, a square root of x minus a square root of y is common. Then I'm going to get a square root of x plus a square root of y minus 1 is equal to 4. Now, since they are integers, x and y are integers, and then you are going to get this multiplied by this is equal to 4, so that we can say that this 4 can be 1 times 4 or 2 times 2. Clearly, these two cannot be equal. You can put them equal, therefore, to see what will happen. But if they are not equal, one of them should be 4 and one of them should be 1. We can easily see that the square root of x minus square root of y is smaller than the square root of x plus the square root of y minus 1. So we can see that here the square root of x minus the square root of y can be equal to 1, then the square root of x plus the square root of y minus 1 is equal to 4. Now from here, if I add these two together, these two equations, add them, you can get 2 square root of x minus 1 is equal to 5. That gives us 2 square root of x is equal to 6, so that the square root of x is equal to 3, then x is equal to 9. Therefore, we got the value of x. Now you know that the square root of x is 3, therefore here you can say substitute in the equation, any equation you are having, equation 1 or equation 2, doesn't matter. If I substitute in equation 1, I'm going to get 3 plus the square root of y is 7. This is sub in 1. You are getting this one. Therefore, the square root of y is equal to 2, so y will be equal to 4. These are the two solutions for this equation. Thank you for watching.